2.6, look at implicit differentiation. And here's where we're taking, so not necessarily a function by definition, since a function is where it passes the vertical line test, but we're going to derive relations. So difference relation is where you don't have a function, so it's like square root. Square root would be a relation, not necessarily a function, because it doesn't pass the vertical line test. So the square root of x is more of a relation than actual function, even though I always call it a function. Technically, it is not. So relations are not functions. Okay, so now as we do this, you can remember when we do f prime of x, right, is one notation, or dy over dx means I'm taking the derivative, or the derivative of y with respect to x. Means it's in terms, it's always y equals in some form of x, right? So here's my independent variable, here's my dependent variable. So I'm finding the derivative with respect to x. So these relations that we have will have two things in them, x and y. So our relations are going to have some form of x and y in them. So we want to find our dy over dx, but now we're going to have both y's and x's in our equation. So normally we're equal to y equals. Here we're equal to 25. So when I derive this, I'll show you how to do it one way in terms of dy over dx, or we can go in the form of y prime, which is not, you still have to do the same steps. It's just you just have to write y prime instead of this dy over dx. So it's kind of just different form. So what I have to do here is dy over dx means in terms or with respect to x, so in terms of x or respect to x. So when I derive this, that's fine, 2x squared. But when I derive this y squared, well, that's not in terms of x. So therefore I have to use chain rule on it. All right, so we're going to do the derivative of the outside, which is 2y, drop the power, and then I got to times that by the derivative of the inside, which is the derivative of y. So I'm going to use the y prime first, and then I'll come back to the dy over dx. So that's y prime equals the derivative of 25, which is just 0, because derivative of a constant is just 0. Now what I need to do is just solve for y prime, so get y prime by itself. Okay, so we're just going to move this over. So basically how this works is, dy y prime, negative 2y y prime, is you just take the derivative and just times, whenever you have a y in there, you just times it by y prime. That's the easiest way to kind of explain it. I did it again. Y prime. It's multiplication, so really it wouldn't matter. I did not derive that correctly, so you're probably wondering that. All right, there we go. Okay, so y prime is equal to 2x over negative 2y, which that reduces to y prime equals negative xy, x over y. And so you could write this y prime as dy over dx. So I think this is the easier way to do it, just in terms of y prime. I'll show you later at the end, so then I don't take so much time, because it's a little bit longer the other way, but not really. So here's another way you can pause the video and you can practice it. Right, and basically I'm taking the derivative of both sides. Right, so that means I'm taking the derivative of both of these, and that's a y, not a g. So this one's just fine, because it's in terms of x. So that would be drop the power, good. This one's where we have problems with because it's not in terms of x. So that's where you do chain rule, derivative of the outside, and then times by the derivative of the inside, which is just the derivative of y. Derivative of x is just 1, and now we just solve for y prime. So this time I'm going to subtract 8x. Oops, x. So 4y prime equals 1 minus 8x. Can't factor anything out here. So you can't cancel the 4 and the 8 because you can't factor out anything from the 1. So what will happen here is you'll be asked to, maybe given a point, some point like 1, 4, and asked to find something or other. And so then you would just plug in your 1 for x and your 4 for y, and then you would solve y prime because y prime is still looking at the slope. So if you're asked to find the slope at this point, you can plug in your 1 and you can plug in 4 for your y, and then you can find out what y prime is, your slope or your velocity. Okay, so this one's a little bit tougher. You're going to do the same thing, except for here is product rule. So this is kind of where it gets a little confusing because this is product rule. So this is my f and this is my g. So there's f is 6x. So f prime, which is fine, it's just 6. But when we do g, we have y, and the derivative of that, I need to start putting my apostrophes in there, is y prime. Okay, so derivative of this, right, I'm taking the derivative of both sides. Derivative of this is chain rule. So see how I'm just attaching a y prime to my derivative of it? Basically, you can just do it in terms of that. So this is product rule, so that'd be f prime times g plus f times g prime. So f prime is 6 times g is y, then plus f, which is 6x, times the derivative of g prime, which is, or derivative of g, which is y prime. And so here is a little confusing. So what you want to do is just take the ones with y prime in them, those terms, and put those together on one side. So I'm going to move those to one side. And then what you're going to do is just factor out that y prime. So you'll factor out the y prime, left with 6x minus 3y squared. And then you'll just divide by what is not y prime, right? Because this is multiplication here, so I can get rid of it by division. So the hard part here is doing product rule, especially if, you know, it's other than just y there. 6x times y, if it's 6xy cubed or something like that. But you'd have to do product rule, and then the second part is just figuring out from right here, this blue part, how to get down to our actual answer of y prime equals, or dy over dx equals. And again, if you're given a point, you would plug in your x for these two x's, and then plug in your y for these two y's, and you'd solve for y prime, which is your slope or your velocity. So it just takes some practice. So you could practice this if you want to. A little bit harder here because this is a sum. I got to take the sum of signs, so how does Sinbad arrange the date? And then here is product. It's a product because this is not a constant, and this is a different, this is a variable. So that's why you have to do product rule there. So you can try this. So one way would just be rearrange the date. Sinbad goes with coset, which maybe this way is actually harder, so you might want to stop here and wait or fast forward or something. And then keeps the signs the same and takes his brother with his sister. So you could do it like that, which maybe is a little bit hard because that's a product rule, that's a product rule. And so here we're going to have to do chain because it's terms of y. Here we're going to have to do chain because it's terms of y, but really that's just, you know, derivative, cosine, negative sine, y, and then times by y prime. This one would be cosine of y times y prime. and here you have product rule. So this is your f and this is your g. So f prime would be 2y, y prime, g would just be negative sine x. So you can go from there if you want to. Or another way would be to go ahead and do chain rule. So you could do chain rule to begin with here. So you could do derivative of sine. So derivative of sine. And then I leave the inside the same, and then I times that by the derivative of the inside. Right? And then I can go ahead and take the derivative of the right side, which is product rule. So either way, you'll get to the same answer. The derivative of this one is just cosine, right? And this is multiplication, multiplying there. This is addition. But here I have to do product rule, right? So I have to do product rule there again. And here actually I have to do product rule. So I'm not quite done. This one's probably just going to be a mess. It's going to take up a lot of room. So maybe that's not the way to go on that one. You still can go that way, but here you have to have three products, right? So I have a product here, and I have a product here, and a product here. I mean, maybe it's going to look the same in the very end, but I think there's probably more steps to do there. So this one might be chain rule. So that's cosine of x plus y, leave the inside the same, times by the derivative of the inside, which is not too bad because those are both linear. And then product rule here, right? We said this is f and this is g. So we take derivative of f, which is 2y prime times g, plus g times, or f, I like to put whatever's not the trig function first. I like to put the trig function second. And so that's going to be negative sine x, the derivative of cosine. So I'm going to change that to negative and sine x. Okay, so the derivative of this one is derivative of x, which is 1, plus the derivative of y, which is the derivative of y. So this one is probably the easier way to go. And then this is multiplication, right? So now I have to get my y primes by themselves. So if you want to pause it here and try it yourself, how to get your y primes by itself. Well, I'm going to distribute this and maybe move this over. Make some room. Cosine of xy plus y prime cosine of x plus y equals 2y prime cosine x minus y squared sine x. So here you just want to get those y primes by itself. So everything that's not attached to y prime, I'm going to put it together. So I'll just move this one, keep that one here, move that y squared to the other side by adding it, and then move the y prime cosine of xy to the other side. Minus y prime cosine xy, x plus y. Divide, factor out a y prime. Divide by that. So divide by that. And there it looks really ugly, but that's okay. Y prime is by itself. Don't really care how ugly it looks. We can try to simplify, but we're not able to factor anything out. So that's a C. So there's our answer right there. And again, if they give us a point, we can plug in an x for all the x's and plug in a y for all the y's and evaluate. So remember, these can look a little bit different just because if I, instead of, what did I do? I left this right here. If I would have left this on this side and moved over this one, then it would look a little bit different with just pretty much the negatives and positives would just be switched around on some of those, but it'd be the same thing. Okay, so that's pretty much it. I would recommend always doing the y prime, but I'll show you real quick at the beginning how you can do it in terms of doing everything with dx, d over dx, and dy over dy. So if we look at this first one, we can, instead of solving for y prime, which is the same as dy over dx, we'll do dy over dx. So looking at this one, we're still going to do the same thing. We're still going to derive both sides. So we're still going to derive both sides. So this is like showing every step. So you don't have to do this. And it maybe depend, if you take calculus somewhere else, it might depend on your professor maybe. And then I'll derive each one. And it's this one that gives us problem because this says in terms of x and we have a y. So this is a constant, so it's 1. This is in terms of x, so we're good. This is where we have problems, so if we multiply both sides by dy over dy, right, my fraction stays fine, y prime, or sorry, y squared. So we multiply that fraction by dy over dy, which is just 1. Right, now I can rearrange this, so I get d over dy times dy over dx. So which this means take the derivative in terms of y. So now I can take this and just times it by dy over dx, which this right here again is the same as y prime. So then we have 2x plus d over dy of y squared. Now I can actually technically take the derivative of that, because now it's saying take the derivative in terms of y, times by dy over dx equals 1. And so 2x plus 2y now dy over dx, which again is just y prime. So we can see that's just the same as before. Now we get the dy over dx by itself, or y prime. And we can see we're starting to get the same answer here. That should be 1. It should be 0. Jeez, it's a constant. It's a constant. So it's 0. Okay, that looks a little better. Okay, now we really actually see that it looks the same. I think I messed up on the first part of this, right? When I took the derivative of x squared, I put 2x squared. Okay, so then we can cancel those and we get negative x over y is our dy over dx. So we see it's the same answer. So I believe the y prime is a lot easier than this part. And maybe technically you do it the other way, but this is easier for me.